9.1a, sequences and series. Here we go. I need a reader. I need a reader. Thank you so much, Cooper, for volunteering. Go for it.
Starting at the top. Alright. An infinite sequence is a function whose domain is a set of positive integers. The function values that
A sub 1, A sub 2.
A sub 3, A sub 4 are the terms of the sequence. If the domain of the function consists of the first n positive integers only, the sequence is a finite sequence.
All right, fantastic. So we usually start with A sub 1 and so on. That's kind of our counting numbers. Now, this A sub n is called the nth term. All right, this is the nth term or the rule of that sequence. Now, a sequence is just numbers listed pretty much. All right, they're not being added. That would be a series. All right. All right, so if it keeps on going forever and ever, it's called an infinite. If it has a stopping point, that's a finite because it stops. Now, on occasion, we're going to start with A sub 0. All right, we're not going to do that as much this year in pre-calc. However, if you take Calc BC, most of the time we actually start with A sub 0 as a 0 set, and then we go on. So we're going to write the terms of the sequence. We're going to write the first 4 terms. So my rule here is A sub n is equal to 3n minus 2. So if I write my first 4 terms, we're going to start with 1. So if I substitute in 1, what do I get? 1. Good job. And then I'm going to get A sub 2. So I'm going to substitute in 2. So what do I get? 4. And then I'm going to substitute in 3. And what do I get? 7. Then I'm going to substitute in 4. And what do I get? 10. Now, what do you notice from term to term? What do you notice going from 1 to 4 to 7 to 10? They're adding 3. However, on the rule, what's it doing? Multiplying. I want you to notice that. All right, that will come into play later. All right, let's look at part B. So now my rule here is A sub n is equal to 3 plus the quantity negative 1 to the power of n. So I need to write my first 4 terms. So A sub 1, if I substitute in 1, I got negative 1 to the power of 1, which is still what? Negative 1 plus 3, we get 2. And then I need to find A sub 2. So I substitute in 2. Now I have negative 1 squared, which is 1. 3 plus 1 is 4. What's A sub 3? Plus 3, which is 2. And then what's A sub 4? 4. What would A sub 5 be? We don't want to find it, but 2. And then 4, and then 2, and then 4, and then 2, and then 4. All right? Because it alternates between this negative 1 and 1 when I substitute in. This is actually called an oscillating pattern. All right? It oscillates between 2 fixed numbers. We won't get to that again until the end of the year. All right, so here we go. We're going to write the first 5 terms of this sequence. So I have A sub n is equal to the quantity of negative 1 to the power n over 2n plus 1. So if I need to start out with A sub 1, what would I get? What would the numerator be? Negative 1 over 3. And then A sub 2. What would the numerator be? 1. What would the denominator be? 5. A sub 3. What do I get? Negative 1 over 7. Then A sub 4. What do I get? 1 over 9. And then A sub 5. What do we get? Negative 1 over 11. Now, when we work with these, if we're going to go backwards, which we soon are, I'd actually ask you to work with the numerator and denominator separately. All right, what's the numerator doing? It alternates between what? Negative 1 and 1. All right. And then, what's the denominator doing? It's adding 2. So guess what happens when we add 2? It's really multiplying on the rule. All right. All right, let's keep moving. So now we're going to go from the terms to write the nth term. All right, we're going to write the rule. So on this first one, I have 1, 3, 5, 7. What's happening? What kind of pattern do we see? It's adding 2. So if we add 2, what should we do? We really should have a multiplying by 2 somewhere. All right, so now I have 2 to the power, or 2 to the n, or 2 times n, dear goodness. All right, so I get 2 times n. However, if I substitute in 1, I should get 1. However, if I substitute in 1 right now, what do I get? I get 2. Well, I don't want 2. I want 1. What should I do to it? I should subtract 1. So now I'm going to subtract 1. Now, here's what I would ask you to do. Pick another term kind of down the line. Like 7 would be my what term? My 4th term. So we should check it. Let's substitute in 4 for n. What do we get? 7. Does it work? Yes. All right. So that would be something that you should probably do. Just check it real quick. It's not going to take very long. All right, let's write out these next ones. I got 2, -5, 10, -17. This one is somewhat difficult. So I'm going to help you out a little bit on this one. What's one thing you notice? It alternates. It alternates. It's one thing you notice. So let's take care of the alternating part. So how do I do that? -1 to the power of n. Now, if I substitute in 1, what do I get? I get a -1 right now. True? I want a positive. I want to start out with a positive. So I start out with -1 to the power of n plus 1. All right? I want to start out positive. So now if I substitute in 1, I get a positive 1. Are you following me? If I substitute in 2, now I'd end up with a negative. All right? So now I got this pattern 2, 5, 10, 17. Is it adding anything? Not really. Is it multiplying anything? Not really. It's really close to 1, 4, 9, 16, is it not? Do you know anything about 1, 4, 9, 16? They're what? They're squares. All right, they're squares, exactly. All right, so how would I write that? I'd write it as n squared. All right, because if I substitute in, let's say, 3, I should end up getting what? 9. Now, they're all off by what? They're all off by 1. So what do I need to do this? It's n squared what? Plus 1. All right. That is a somewhat difficult one for you guys to see sometimes. All right, especially starting out. I want to do another one. So let's say we have 4, 8, 16, 32. Let's say we have 4, 8, 16, 32. I need to write my nth term. What's happening? It's multiplying by 2. All right? So each term is being multiplied by 2. Well, what if when they added by 2, I did what? I multiplied. If they're going to be multiplying by 2, that's actually exponential. All right? That's actually exponential. So my a sub n is actually going to be 2 to the power of n. Because what is an exponential? If I have 2 to the power of 3, that's really 2 times 2 times 2, right? That's being multiplied. If I have 2 times 3, that's 2 plus 2 plus 2. Are you following me? All right, so that's how they kind of work, okay? So if I'm multiplying from term to term, that's actually exponential. Now, if I substitute in 1, I want to get 4. Do I get 4? Nope. What do I get? I get 2. If I substitute in 2, I want to get 8, but what do I get? I get 4. I need to multiply it by 2. Okay, so I want to start talking about that. So my a sub n would end up being 2 times 2 to the power of n. All right, I would give you full credit for that. However, I want to kind of see some laws of exponents. We're going to use some pre-calc, or algebra 2, really. 2 to the power of what? 2 to the power of 1, right? 2 to the power of 1 times 2 to the power of n. True? So they have common bases. When I have multiplication with common bases, what do we do to our exponents? We add them. So this is really 2 to the power of n plus 1. All right? I totally would give you full credit with 2 times 2 to the n. All right? I'd give you full credit for it. However, I kind of want you to start thinking this way. All right? So now if we substitute in, let's put in 4. If we substitute in 4, we get 2 to the power of 5. And guess what we know 2 to the power of 5 is? 32. Hey, it worked out. Okay? Pretty good? All right. Let's keep moving. So I'd like you to try these. All right, negative 2/3, 3/4, negative 4/5. All right, so let's first take care of the alternating thing. All right, so how do I take care of that? Negative 1 to the power of n. Is it negative 1 to the power of n or n plus 1? It's just n. All right, why is it just n? Because which way do I want to start? I want to start negative. All right, and that's the first term. All right, so now let's work with the numerator. What's happening to them? Okay, that's the alternating part. We took care of it. All right, it's adding what? It's adding 1. So now I have 1n, and then what do I need to do with that? I need to add 1. Because if I substitute in 1, I want a 2. If I substitute in 2, I get a 3. All right. All right, and then on the denominator, what's happening? N plus 2. All right, or 1n plus 2. All right, and so if we wanted to, we could check it. Let's figure out, like, let's say our 5th term. If we substitute in 5, guess what we get? Negative 6/7. All right, so hey, it works. All right. All right, so this is what's known as a recursive sequence. It's kind of like a rule or a procedure. So I'd like you to write up a sub k is equal to a sub k minus 2 plus a sub k minus 1. Okay, that's the rule. It's called a recursive sequence. It's not always that one, but that's kind of the rule on this one. And then it gives me some initial conditions. It gives me a sub 0 is 1. And it gives me a sub 1 is also 1. And it's asking me to find the first 6 terms of this sequence. All right, so what do we actually need to go to? We need to get to the first 6 terms, but it starts at 0. We need to get to a sub 5. All right, so I need a sub 2, I need a sub 3, I need a sub 4, and I need a sub 5. All right, so this is where we just follow the rule. So if I have a sub 2, okay, my k is now 2. Does that make sense? So all we're doing is just substituting in 2, basically. So now if I have a sub 2, that's equal to a sub 2 minus 2, which is a sub 0. Well, what is a sub 0? 1. So I really end up having 1. And then this one, I'd end up with 2 minus 1, which is a sub 1, right? And what is a sub 1? 1 again. So I'd have 1 plus 1, which is 2. All right, I'm just following the little rule. So now I need to find a sub 3. Well, if I need to find a sub 3, that's really a sub 1 plus a sub 2. Well, a sub 1 is 1 plus a sub 2 is 2, so I end up with 3. If I need to find a sub 4, I just follow my rules. So a sub 4 is really a sub 2 plus a sub 3. Well, a sub 2 plus 3 is 5. And then what's a sub 5? A sub 3 plus a sub 4, which is 8. What would a sub 6 be? 13. All right, what would a sub 7 be? 21. Very good. All right. All right, factorials are what I like to call happies. All right. All right, so these are factorials, and I think of it as kind of like a countdown. I don't really go forward. I like to go backwards. All right. So if it's 4 factorial, it would be 4 times 3 times 2 times 1 blast off. All right. One thing that you should notice on this is 0 factorial is 1. All right. Make sure you write that one down. All right. 0 factorial is still 1. And honestly, that should kind of like tick you off a little bit. All right. However, it's because it's an empty subset, it's still 1. All right. Kind of like 3 to the power of 0. Anything raised to the power of 0 is 1. All right. So it kind of works like that. All right. All right. So we're going to write the first 5 terms of this sequence, beginning with n equals 0. So I need to find a sub 0, a sub 1, a sub 2, a sub 3, and a sub 4. Why do I not need to go to a sub 5? Because I start at 0 on this one. All right. So if I substitute in 0, I have 2 to the power of 0, which is 1, over 0 factorial, which is 1. So I end up with 1. Now we need to find a sub 1. So now I end up having 2 to the power of 1, which is 2, over 1 factorial, which is 1. So I end up with 2. And then I substitute in 2. So now I have 2 to the power of 2, which is 4, over 2 factorial. Well, that would be 2 times 1, which is 2. I can simplify this to be 2. And then I substitute in 3. So now I have 2 to the power of 3. 2 to the power of 3 is 8. So now I have 8 over 3 factorial. Well, 3 factorial is really 3 times 2 times 1. So that's what? 6. Now that one can be simplified again. What could that simplify to? 4/3. All right, now we're going to find a sub 4. So now I have 2 to the power of 4, which is 16, over 4 times 3 times 2 times 1, which is 24. And that one actually can simplify to 2/3. All right. Now we're going to evaluate these factorials, and we don't need a calculator. All right, we don't need a calculator on it. So I have 8 factorial over 2 factorial times 6 factorial. Okay? I know you did this in Algebra 2. I might do it slightly different that makes a little bit more sense. What is 8 factorial? It's 8 times what? 7 times 6 factorial. So I'm going to say 8 factorial is 8 times 7 times 6 factorial. Why did I do that? So I can cancel it. Okay? Now, I know last year, I think you wrote them all out. And then you canceled out all the 6s, and then all the 5s, and all the 4s, all the 3s, and all the 2s. I don't understand why. Okay? Figure out which factorial is bigger, get to the other one, cancel them. Are you following me? All right, don't write all 5s, 4s, 3, 2, 1s. All right, that's silly. All right, and then 2 factorial is what? 2. So now we can do this in our head, and if I felt like it, I could even do 8 divided by 2 first. What's 8 divided by 2? 4. 4 times 7? 28. There we go. We're done. All right. Hi there.
Is that why when you went from the very first thing to factorial, you just lost the exclamation point or whatever because it's going to be 2?
Yep. All right. All right, let's look at part B. Now I have 2 factorial times 6 factorial over 3 factorial times 5 factorial. All right? And we can easily do this without a calculator. So my biggest one is 6 factorial, right? That one's really close to 5 factorial, right? Well, what the heck is 6 factorial? It's what? 6 times 5 factorial. I'm going to stop right there. Because what can I do? I can cancel out the 5 factorials. You following me? And then I have 2 times 3 factorial. Well, which one's bigger? The 3 factorial. Well, what's 3 factorial? It's 3 times 2 factorial. I'm going to stop there because I can cancel out my 2 factorials. So what am I left with? 6 over 3, which we know is 2. All right. It's a lot less time consuming than writing out all of those things, which I don't understand why we need to do that. Okay? All right. Let's look at these now. Okay, now we have some variables with it, and this is actually more useful in Calc 2. So now I have n factorial over n minus 1 factorial. Before I start, what's like 8 factorial? It's 8 times what? 7. I'm going to call 7 8 minus 1. Because that's really what we do, isn't it? And then times 6. But I'm going to call that one 8 minus 2. Are you following me? And then I'd have 8 minus 3, and then 8 minus 4, and then 8 minus 5, right? That's what I'd be multiplying by. Well, if I have n factorial, what's my next one? N minus 1. And then n minus 2, and then n minus 3, and so forth. So I have n factorial over n minus 1 factorial. Which one's bigger? N factorial is bigger. Well, what is n factorial? It's n times what? N minus 1 factorial. That's where I'm going to stop. Because I can cancel these now. So guess what I'm left with? Just n. All right. I want a freestyle one. So let's say I have 2n, the quantity of 2n minus 1 factorial over 2n plus 1 factorial. Which one's bigger? 2n plus 1's bigger. Does everybody agree with that? All right. So what is 2n plus 1 factorial? It's really what? 2n plus 1, right? And then times what? Let's subtract 1 from it. 2n. And then times what? 2n minus 1 factorial. That's where I want to stop. Because now, what can I do with it? I can cancel them. All right. However, what's left up top? A 1. It's got a placeholder. All right. And so my answer would end up being 1 over 2n times 2n plus 1. I don't know. I just like to bring out the 2n first. I don't know why. Okay. And that would be our answer. All right. Some people ask, do you want to distribute? I say no. All right. Leave it in factored form. It's actually easier to work with. Okay. And it's less work for you. All right. Hi there. Worksheet 9.1a.